minutes to go over some more stuff with ellipses and go over some other ways that questions might be asked and how you can get through those questions knowing what you know about ellipses. So this is an example of a different way that a question might be asked. It says, this ellipse is centered at the origin, find its equation. So it gives you the vertices and it gives you the foci. Remember that the general form, right, x squared over a squared plus y squared over b squared is equal to 1. That would be centered at the origin with a horizontal major axis. And if we had x squared over b squared plus y squared over a squared equals 1, that means it would be an ellipse centered at the origin with a vertical major axis. So again, like I was saying before, we want to make sure that we visualize this by sketching a quick graph. Again, all we have to do is, it doesn't have to be anything fancy, but something to just give us kind of a reference point as to where we are. So in this particular problem, it says we've got vertices at negative 2, 0, and 2, 0. So negative 2, 0 would be here, and 2, 0 would be here. And foci at negative 1, 0, and 1, 0. So our foci, I'll do that in blue, that would be here and here. Remember, the foci are always along your major axis. So we know that our major axis is horizontal, which means that we're going to be using this form. Okay, so how do I figure out what A is and what B is? Remember that we said the distance from the center to one of the vertices is going to be that distance A. So if this point out here is 2, 0, that means A is going to be 2. I also know that the distance from the center to the foci is C. So this distance here would be C. And since the coordinates at that point are 1, 0, I know that C is going to be 1. So again, visually it helps to sketch yourself a picture so you can see what's going on. Remember that we also said to find the foci, we would use the equation or the formula C squared is equal to A squared minus B squared. Well, I have C and I have A, so I can easily find B. C squared would be 1. A squared would be 4. So I have 1 equals 4 minus B squared, which means that negative 3 is equal to negative B squared, which means that B squared is equal to positive 4. Now I could go through and solve for B, but I don't need it. Remember, what goes in the equation is B squared. So I have basically what I need. If A is 2, I know that A squared is going to be 4. So I have the two values that I need. I just have to make sure I put them in the right place. Remember, we said this is a horizontal ellipse, which means that the larger number is going to be under the x squared. So this would be 4, and this would be 3. Again, when you're doing a problem like this, just sketch it out. Figure out which way your ellipse is oriented, whether it's a horizontal ellipse or a vertical ellipse. And then use C squared equals A squared minus B squared to find whatever missing value you need. Sometimes they give you an equation in this form, and this doesn't look like anything that we've done so far. So actually, I'm going to come back to this one. I want to look at this one first. This also looks a little bit different than what we have done before, because of the fact that there aren't any fractions here, and we've got on the right hand side something that doesn't equal 1. So all it takes is a little bit of manipulation to get it into a form that we recognize. So all we would need to do here is to go ahead and divide everything by 784. That way I get the other side of my equation, the right-hand side of my equation, to equal 1. So 49 goes into 784. I have my calculator's not working. Oh, there we go. Okay. 784 divided by 49. Right, so that means that would reduce to x squared over 16. Which means that 16 goes into 784 49 times over 49 is equal to 1. Right? So all I did was took that term on the right hand side and divided everything by that so I could get it into a form that I recognize. Okay? And again, from here, it's pretty straightforward. The larger number is under the y, which means that it is a vertical ellipse, and our major axis is along that vertical. Okay, and then you know how to find the foci. The foci is just c squared is equal to a squared minus b squared. So I'm not going to do that whole problem because I think you know how to do the rest of it. I just wanted to explain to you how you get it into a form that you recognize. So let me double back then to this. Clearly this is not in a form that we currently recognize. So we're going to have to get it into a form that we recognize, which requires us to complete the square. We're going to have to complete the square on the x terms as well as the y terms. So let me kind of go through how you would do that. The first thing you want to do is group your x terms together, group your y terms together, and move the constant term over to the other side. So that would give me x squared minus 10x. And then I'm going to leave a space. And then I've got 4y squared minus 40y, and then I'm going to leave a space because remember I'm going to complete the square, and then I'm going to subtract 121 from both sides. Okay, so all I did was rearrange my terms. Remember to complete the square, you take half of that x term, so half of negative 10 would be negative 5. And then if I square negative 5, I get positive 25. So I'll do that in different color. I'm going to get positive 25, and whatever I do to one side, remember I have to also do to the other side. So if I add 25 here, I need to add 25 here. Also, when we are completing the square, we can only do it if that leading coefficient on our squared term is 1. And if you look at the y's, we have a leading coefficient of 4. So this isn't going to work in the form that it's in. So what I'm going to do is I'm going to factor a 4 out of both of these terms. So to do that, I'm going to end up with this. So I've got 4. And then I've got y squared minus 10y. So I took 4 out of both of those terms, and that just leaves me with what I have in parentheses. So again, I'm going to complete the square, but here's where you have to be really careful, and it's very easy to make this mistake. I complete the square the same way. I take half of negative 10, and I square that. Half of negative 10 is negative 5 squared. I get positive 25. Remember I said whatever you do to one side, you have to do to the other. But be careful here, because this isn't just 25. If I redistribute the 4, it would be 4 times 25, or 100. So I would have to add 100 to this side, because when I distribute, 4 times 25, oops, 4 times 25 gives me that. But now I have this in a form that's going to be much, much easier to then turn into a form that we recognize. So if I look at this and I write this as a square of a binomial, I have x minus 5 squared. Remember, to write it as a binomial, you're just using half of that middle term. So half of negative 10 is negative 5. Here I've got 4. And then I've got y minus 5 squared. And then over here, I have 125 minus 121, which would be 4. Now, again, I still am not in the form that I know how to work with because of the fact that this here is not a 1. Just like I did on that last problem when I divided everything through by 784, here I'm going to divide everything through by 4 to get this side of my equation to be 1. So I end up with x minus 5 squared over 4 plus y minus 5 squared over 1 is equal to 1. And that might make it easier if you keep that y part over the 1 so you can see what your a and your b is, your a squared and your b squared and all of that. In this particular problem, they're just asking you to find the center. Now that you have it in a form that you recognize, you can easily find the center from that. Okay, so hopefully that helps with that. I'm going to actually do the other problems in a separate video, so that'll be coming up next. Thanks, everyone.